The cliff face begins as a color before it becomes a fossil site. Red sandstone, orange in the low sun, rising from the Gobi floor in broken walls and ledges, as if the desert has been cut open and left to weather. Wind moves across it constantly. Grains of sand tap against boot leather and bone fragments and the dry stems of shrubs. In the distance, the land looks almost empty. Then, the eye adjusts. A skull lies partly exposed beneath a slope of loose sediment. A curved eggshell fragment catches the light. A small jaw, still holding teeth, rests in rock that was once a dune. This is the strange power of the Gobi dinosaur graveyards. They do not look like forests turned to stone, or river channels packed with giants, or swamp beds dark with leaves. They look like the remains of animals that met the desert too suddenly. A nest covered before it could hatch, a body folded into sand, two dinosaurs locked together when the ground around them gave way. The animals here were not the largest of the Mesozoic, but the way they were preserved makes them feel close in a way that size alone never could. The fossils in these rocks belong mostly to the late Cretaceous, long after the Jurassic giants had already lived and vanished. Around 70 to 80 million years ago, parts of what is now Mongolia and northern China were dry, open, and restless. Dunes moved through the landscape. Short-lived ponds formed and disappeared. Rain could arrive hard enough to destabilize slopes of sand and then leave again, returning the region to wind, heat, and dust. It was a dinosaur world, but not the kind usually imagined with dripping forests and deep green shade. The formation most closely tied to this world is the Jadakta Formation, a body of red and orange sandstone famous for preserving Protoceratops, Velociraptor. Oviraptor and its relatives, small mammals, lizards, eggs, nests, and animals caught with startling completeness. The most famous locality, Bain Zak, became known to English-speaking expedition members as the Flaming Cliffs because of the way the rocks glow in late light. The name sounds dramatic, but the landscape does not need the help. The color is enough. The fossils are enough. At first, the desert gave paleontologists what they were not looking for. The American expeditions that crossed the Gobi in the 1920s went searching for deep human ancestry and came back with dinosaurs, mammals, and eggs. The mistaken purpose did not matter. Science often advances this way, not by finding exactly what it expected, but by standing in front of something stranger and admitting that the ground has changed the question. The Gobi did that again and again. If these journeys into the dinosaur age are what draw you back to Jurassical, subscribing keeps the next one close. The first great image is a nest. Not a nest of twigs, not the open bowl of a modern bird, but a ring of long eggs, partly embedded in sand. The eggs were not round. Many dinosaur eggs were elongated, tapering slightly, arranged in patterns that suggest deliberate placement rather than accident. In the early years, the eggs from the Flaming Cliffs were thought to belong to Protoceratops, because Protoceratops was common nearby. It seemed reasonable at the time. The small, horned dinosaur was everywhere in those beds, and the eggs had to belong to someone. Then, Oviraptor entered the story and carried the wrong reputation for decades. Its partial skeleton was found close to a clutch of eggs, and its name came to mean egg thief. The picture was simple and memorable. A predator, caught in the act of raiding another dinosaur's nest, buried by sand before it could escape. It was the kind of story that fossils sometimes invite too easily, because bones preserve a moment while leaving out the minutes before it. The animal's name hardened around an interpretation that later evidence would weaken. What changed the story was not a single dramatic argument. It was another fossil, and then another, and the quiet pressure of better evidence. Oviraptor-like embryos were found inside eggs of the same general kind. Oviraptorid adults were found positioned over nests in postures that looked less like theft and more like brooding. Their bodies were placed above the clutch, limbs arranged around the eggs, as if they had been covering them in life. The egg thief became a parent, or at least an animal closely tied to its own nest. That change matters because it turns the Gobi from a place of sudden death into a place of behavior. Fossils are often treated as objects, but a nest is never only an object. A nest is time invested. It is a site selected, eggs laid, perhaps guarded, perhaps warmed or shaded by a feathered body. It is the future arranged in a circle. When the sand covered those eggs and the animal above them, it preserved not just bones, but a decision repeated across generations. Oviraptor itself was not a giant. The original species, Oviraptor Velociraptor, came from the flaming cliffs, but many of the most informative brooding fossils belong to close relatives such as Cetipati. These oviraptorids were theropod dinosaurs, part of the broader lineage that includes birds. They had toothless beaks, long arms, and bodies that were likely feathered. Some had skull crests. Their hands and arms were not bird wings in the modern sense, but they belonged to animals close enough to birds that their nesting behavior carries a familiar shape. Imagine one of them on a dry rise near a dune field. The eggs are already in place, set in a ring around the center of the clutch. The parent lowers itself carefully, not crushing what is beneath it. The arms extend outward. Feathers, if present across the forelimbs, create shade over the outer eggs. There is no song here, no flowering branch above the nest, no grass moving in the wind. Only sand, low shrubs, heat, and the repeated act of staying. Protoceratops lived in the same world, and it became one of the defining animals of the Gobi Cretaceous. It was a small ceratopsian, a relative of the later horned dinosaurs, but without the great brow horns of Triceratops. Its skull carried a beak at the front and a frill at the back. Adults were roughly sheep-sized to pig-sized depending on the individual, heavy enough to leave deep tracks in soft ground, but small compared with the immense ceratopsians that would dominate parts of North America later. The skull of Protoceratops is one of the reasons the animal feels so knowable. The beak gives it a plain strength. The frill gives it a profile that changes as it grows. Juveniles carried smaller, simpler skulls, while adults could develop broader frills and stronger jaws. A row of teeth behind the beak processed tough vegetation from a dry environment where every mouthful had to be taken seriously. This was not a lush meadow grazer. It was a desert herbivore, built to live where food arrived in patches. The old idea of the Gobi as an empty wasteland needs correction. The late Cretaceous Jadocta environment was dry, but not lifeless. It held plants, insects, lizards, mammals, birds or bird-like dinosaurs, small theropods, armored dinosaurs in nearby deposits, and the low, practical activity of animals finding food and water. There were ponds that came and went. There were interdune areas where moisture gathered. There were surfaces firm enough for animals to walk across and loose enough to fail under pressure. The failures are what made the graveyards. A dune face can seem stable until water changes it. Rain hits dry sand, runs through the slope, adds weight, loosens structure, and turns a quiet surface into moving sediment. A sand avalanche does not need to look like a mountain collapse to be deadly. For a small dinosaur, for a nesting adult, for a mammal caught at the wrong burrow entrance, it could arrive fast enough to bury the body before scavengers reached it. Not every Gobi fossil was made by the same event. Some animals may have died in burrows, some may have been covered after ordinary death. Some may have been trapped by collapsing dunes, others by storm-wet sediment sliding from a slope. The word sandstorm can suggest a wall of dust sweeping across the desert, and storms almost certainly mattered. But the fossil record points just as strongly to avalanches and sand flows triggered by rain and unstable dune faces. The important point is speed. The sand arrived quickly, and the bodies were sealed. That is why the fossils can feel intimate. A skeleton that lies complete in a desert deposit is not only a collection of bones, it is a body that escaped the usual disappearance. No long season of scavenging, no river carrying the pieces away, no slow scattering beneath sun and teeth and weather. The sand took the animal before the surface world had finished with it, and millions of years later the cliff gave it back. Among all the fossils from this desert, none is more immediate than the fighting dinosaurs. One animal is Velociraptor mongoliensis. The other is Protoceratops andrewsi. They are preserved together, not as loose bones from the same bed, but as bodies entangled. The Velociraptor's sickle claw is near the neck or throat region of the Protoceratops. The Protoceratops has its beak clamped around the predator's arm. It is one of the rarest things paleontology can offer, not just evidence that one species lived with another, but evidence that two individuals physically met. The scene should not be exaggerated. Fossils do not give us sound. They do not tell us whether the fight began at a nest, over a carcass, at a water edge, or in some brief collision of hunger and defense. They do not say which animal was winning. What they do show is contact. A predator and a herbivore locked tightly enough that when sand buried them, they stayed together. The moment survived because the world around them failed at just the right time. Velociraptor in the Gobi was not the oversized animal made familiar by films. It was much smaller, closer to a wolf or large turkey in body size than a human-height monster. But it was still dangerous. It had a long skull, serrated teeth, grasping hands, a stiffened tail for balance, and the famous enlarged claw on the second toe. It was likely feathered, like many dromaeosaurs. Its power did not come from bulk. It came from precision, speed, grip, and the ability to attack animals that could still fight back. Protoceratops could fight back. Its beak was not ornamental. Its jaws were strong. Its body was low and compact. Against a much larger predator, it might have relied on numbers, vigilance, or simply the difficulty of killing a sturdy herbivore. Against Velociraptor, the struggle could be more equal. One animal carried claws and teeth. The other carried a beak and weight, and the stubborn leverage of a body built close to the ground. In the fossil, the fight is over, but not resolved. That is why it holds attention. No living eye saw the final seconds. Maybe the sand came while both were exhausted. Maybe the slope collapsed beneath them. Maybe one was already dying, and the other could not pull free. The desert did not preserve a victory. It preserved a knot of bodies, and the knot is enough. Around that single famous specimen lies a broader desert full of quieter evidence. Protoceratops skulls appear in numbers that suggest the animal was common in parts of the Jadakta ecosystem. Juveniles and adults help researchers think about growth. Different frill shapes and skull proportions have invited debates about age, sex, species variation, and regional difference. In a fossil field, abundance is not just repetition. It is a way of seeing life in population, not only as isolated skeletons. A single Protoceratops can tell us about anatomy. Many Protoceratops can tell us about a world. They show that this animal was successful enough to leave its bones across the desert in quantity. They suggest herds or at least repeated gatherings in places where food and water were available. They hint at the pressures of a dry ecosystem where juveniles were vulnerable, adults still at risk, and predators learned where herbivores returned. The Gobi record is good, but it is not complete. Preservation favors certain places and certain disasters. A dune field that buries bodies quickly will give us a different fossil record than a forest soil where bones rot and vanish. That means the Gobi may overrepresent sudden burial events and underrepresent the ordinary days between them. For every animal sealed in sand, many others died unseen and left no trace. Paleontology begins with what survives, then works outward toward what probably surrounded it. The Jadakta animals lived near the end of the long Mesozoic story, but before the final asteroid impact. Tyrannosaurus had not yet reached the Gobi. Triceratops did not live here. The world was regional, divided by continents, climates, basins, and barriers. In Mongolia, desert-adapted communities developed their own character. Small horned dinosaurs, dromaeosaurs, oviraptorids, alvarezsaur-like insect hunters, ankylosaurs in related deposits, mammals and lizards all occupied a dry Cretaceous stage very different from the floodplains of Western North America. That difference is part of the value. Dinosaurs were not one world. They were many worlds spread across the Mesozoic, a sauropod forest in the Jurassic, a coastal hadrosaur plain, a polar conifer woodland, a Gobi dune field with Protoceratops nests and Oviraptorid clutches. Each place changes the meaning of the animals. Velociraptor in a desert is not only a predator. It is a predator of sand, sparse cover, hard light, and sudden burial. The desert also preserves smallness. Early mammals appear in these beds as skulls and jaws and delicate skeletons, sometimes with astonishing completeness. In many fossil sites, animals that small vanish from the record because their bones are too fragile and too easily scattered. In the Gobi, quick burial could protect them. A mammal the size of a rodent, living beneath the feet of dinosaurs, could become part of the same stone archive as a Protoceratops skull or an Oviraptorid nest. These mammals were not rulers of the ecosystem. They lived in burrows, in shade, in the spaces between larger bodies. Some fed on insects, some may have used strong forelimbs or digging claws. Their presence reminds us that the dinosaur age was never only dinosaurs. It included small furred animals, lizards moving across hot sediment, insects leaving trails, plants gripping the edges of dunes, and the hidden activity of life at ground level. A fossil graveyard can mislead if it is imagined only as a mass death site. Some Gobi localities are more like repeated traps, places where animals died at different times, but under similar conditions. Others preserve nests or individuals rather than crowded bone beds. The phrase graveyard is useful because it captures the density of death in the rocks, but the real story is more varied. It is a landscape where certain kinds of death were unusually likely to become fossils. Sand is not gentle in life. It abrades skin, fills eyes, covers tracks, buries eggs, and moves under wind with patient force. In death, under rare conditions, it can become protective. It can surround a body so closely that the skeleton remains articulated. It can hold the curve of a neck, the placement of limbs, the pattern of eggs in a clutch. The same material that erased ordinary traces preserved the extraordinary ones. This is why the Gobi continues to matter. It is not simply because the fossils are famous, though they are. It is because they preserve behavior, environment, misinterpretation, correction, and the shape of scientific humility. The desert gave paleontologists eggs, and they first assigned them to the animal that seemed most obvious. The desert gave them Oviraptor, and they gave it a name that reflected a story later overturned. The desert gave them fighting dinosaurs, and even there, where the evidence is unusually vivid, the final meaning remains cautious. The rocks keep their distance. They show enough to pull us close, then stop before certainty becomes easy. A beak around an arm, a claw near a throat, a parent over eggs, a skull weathering out of red stone. These are not complete stories. They are preserved openings, and every careful reconstruction begins by respecting what they do not say. To stand at the flaming cliffs is to stand in two deserts at once. One is modern, with wind, heat, vehicles, field jackets, maps, and people searching the slopes for bone. The other is Cretaceous, with dunes, small dinosaurs, nests, brief water, and storms that could turn sand into a moving wall. The cliffs are the boundary between them. Every fossil comes through that boundary carrying part of both. The modern Gobi is not identical to the ancient one, but the comparison helps. Drylands are not empty. They are systems of scarcity and timing. Water matters because it is rare. Shade matters because heat is constant. A small depression can become a pond. A patch of vegetation can draw herbivores. A dune face can hold until it does not. The Jadakta ecosystem seems to have worked through that same logic, with animals adapted to a landscape where survival depended on finding resources before the desert took them away. Protoceratops may have fed on tough, low vegetation, cropping plants with its beak and processing them with cheek teeth. The exact menu is uncertain because plants are not preserved as completely as bones in every locality, but the animal's jaws point toward a herbivore that could manage fibrous material. It likely spent much of its day doing what herbivores do almost everywhere: lowering the head, biting, chewing, lifting, looking, moving, and repeating the work. A young Protoceratops would have seen the world close to the ground: sand at eye level, stems and roots, the legs of adults, shadows of theropods passing too near. Its frill would have been small, its body less able to resist attack, its survival tied to growth. Many did not reach adulthood. That is not tragedy in the human sense. It is the mathematics of animal life. Enough survived for the species to remain abundant. Many vanished to feed others. Velociraptor lived inside that mathematics. It did not need to be a monster to matter. A predator of that size could survive on juveniles, lizards, mammals, carrion, eggs, and perhaps wounded or isolated larger prey. Its body suggests agility rather than brute force. The sickle claw was part of a hunting toolkit, but not a magic weapon. It would have been useful only when the animal could bring the rest of its body into the struggle, balancing, gripping, and avoiding the bite that might break bone. The fighting dinosaurs fossil is often treated as direct proof of predation, and it may be. Yet the exact cause of the encounter remains uncertain. The two could have been fighting over a nest. Velociraptor may have attacked a living Protoceratops. It may have approached a weakened animal. The Protoceratops may have defended itself with unexpected force. Scientific caution does not weaken the fossil. It strengthens it by keeping the interpretation close to the evidence. Evidence is the difference between a scene and a fantasy. We can imagine the weight of the Protoceratops, the snap of the beak, the claw driven in, the sudden movement of sand. But the fossil only confirms contact, injury, and burial. Everything else must be built carefully around those facts. The most powerful reconstructions are not the ones that shout, they are the ones that know when to stop. The same caution reshaped Oviraptor. A name can carry an old mistake long after the mistake is known. Oviraptor still means egg thief, but the evidence now points toward a more complex reality. The animal associated with eggs was likely not stealing them in the simple way once imagined. Oviraptorids nested. They arranged clutches. Some appear to have brooded in bird-like positions. The thief became apparent because new fossils made the old story too small. Those nests were not casually scattered. Many oviraptorid clutches show eggs arranged in rings or arcs, often with open space toward the center. This layout suggests a body positioned over or within the clutch without crushing the eggs. The eggs were often paired or organized in repeated patterns. Reproductive behavior leaves traces that are harder to preserve than bones, but when eggs remain in place, their geometry becomes evidence. There is something restrained and moving about an animal fossilized over its nest. It does not need to be made sentimental. The body tells enough. A theropod lowers itself above a clutch in a dry Cretaceous desert. The eggs are not yet young, not yet movement, not yet hunger. Then, sand comes down. In the rock, the animal and the future it guarded become inseparable. Brooding does not mean the animal behaved exactly like a modern bird in every way. It does not prove vocal care, feeding of hatchlings, or lifelong parental bonds. It shows posture and association. It shows that some non-avian theropods use their bodies in relation to eggs in a way that resembles avian nesting. That is already enough. It connects behavior across the dinosaur-bird transition without needing to turn Oviraptor into a bird in costume. The Gobi is full of these partial connections. Oviraptorids are not birds, but they show bird-like reproductive behavior. Velociraptor is not the film creature, but it is a feathered dromaeosaur close enough to birds to change how we imagine predators. Protoceratops is not Triceratops, but it belongs to the ceratopsian story before the great horned giants. Small mammals are not yet dominant, but they carry the lineage that will later inherit many empty spaces. Deep time is not a ladder. It is a crowded landscape of experiments. The Gobi captures several at once: beaked theropods over eggs, horned dinosaurs before horns became immense, feathered predators in dune fields, mammals in the margins, lizards in hot sand, and a desert that could end a life and preserve it in the same motion. The graveyards are not a single chapter. They are a page where many chapters overlap. The Central Asiatic expeditions made that page visible to the wider world. In the 1920s, motor vehicles, camel caravans, field camps, and survey teams crossed regions that were difficult to map and harder to work. Roy Chapman Andrews became the public face of those expeditions, but the finds depended on many people, including field assistants, preparators, drivers, local workers, and scientists, whose names did not always travel as far as the fossils did. The history is exciting, but it also belongs to a colonial and international moment that should not be flattened into adventure alone. Fossils from Mongolia became museum specimens far away. Scientific value traveled with them, but so did questions about ownership, national heritage, and how paleontology should be practiced. Today, Mongolian fossils are recognized not only as scientific data, but as part of Mongolia's natural history, protected by laws and by growing local expertise. That matters because the Gobi is still not finished. New expeditions, many involving Mongolian scientists and institutions, continue to refine the picture. Fossils once thought to belong to one animal can be restudied. CT scans can reveal hidden skull structures. Eggshell microstructure can be compared. Sedimentology can show how a body was buried. The old dramatic discoveries remain important, but modern work often changes their meaning by asking quieter, more precise questions. A field worker today may still find the past the way it was found a century ago, not as a complete skeleton standing upright, but as a small surface detail. A bit of eggshell, a tooth, a line in the sandstone that does not quite belong to the rock. The desert gives hints before it gives bodies. A fossil begins as an interruption in the color of the ground. At Bain Zak, the red sandstone breaks into shelves and slopes. At Tugrikin Shire, the fighting dinosaurs came from deposits that speak to sand movement and sudden burial. At Uka Tolgod, exquisitely preserved mammals, lizards, and dinosaurs made the Gobi seem even more detailed than earlier expeditions had imagined. These localities are not identical, but together they form an archive of a dry Cretaceous world. The word archive is useful because the desert did not preserve everything equally. It kept what conditions allowed. Dune sands preserved skeletons in 3 dimensions. Fine sediment protected small bones. Rapid burial locked nests in place. But soft plants, skin, colors, calls, mating displays, and most daily movements disappeared. The archive is rich, but damaged. Reading it requires knowing the missing pages are missing. Still, enough remains to enter the world. A Protoceratops skull on a lab table is not only a skull, it is the front of a living animal that once breathed dusty air through nasal passages, cropped plants with a beak, turned its head toward movement, and carried muscle across the bones now bare. A fossil egg is not only a shape in stone. It is a shell that once separated a developing body from the desert outside. The eggshell itself can tell a story. Dinosaur eggshell has layers and pores. Pores allow gases to move between embryo and environment. The number and arrangement of pores relate to nesting conditions, including whether eggs were buried or exposed. In oviraptorid nests, egg arrangement and adult posture suggest a reproductive system that combines some reptile-like and bird-like features. The animals were not simple stepping stones. They were functioning organisms with their own successful strategies. Protoceratops eggs are more difficult to identify than early researchers thought. Fossil eggs without embryos can be hard to assign, because many species may have nested in the same region, and eggshell shape alone may not be enough. That was the root of the original mistake at the Flaming Cliffs. The most common nearby dinosaur seemed like the most likely parent. Later, an embryo inside a matching egg changed the assignment. The shell had waited for the right evidence. Science often moves this way, not by throwing away the past entirely, but by placing a better fossil beside it. The old interpretation becomes a record of how people reasoned with limited evidence. The new interpretation becomes stronger because the mistake is visible. Oviraptor did not lose its name, but the name became a reminder that fossils can be honest while our first stories about them are wrong. The Gobi graveyards are therefore not only about dinosaurs dying in sand, they are about the way knowledge itself is buried and uncovered. A nest becomes Protoceratops, then Oviraptorid. A predator becomes a cinematic monster, then a smaller feathered animal with more interesting biology. A desert becomes empty, then crowded with mammals, lizards, eggs, and tracks of behavior. Each discovery removes one layer and reveals another. To understand the animals, it helps to begin with the ground under them. The Geoducta deposits were laid down in a semi-arid setting with windblown sand, dune fields, and some water-laid sediment. The rocks often include cross-bedding, the slanted layers that form when dunes migrate. These structures are not decoration. They are fossilized motion, the preserved angle of sand as it slipped down the lee side of a dune millions of years before any human footprint crossed the Gobi. When paleontologists talk about a sand avalanche, they are not imagining an ordinary day of dust. They are reading body position, sediment texture, and the relationship between skeletons and bedding. An animal buried in a dune collapse may be found articulated, sometimes with limbs and postures that suggest a struggle or rapid entombment. Some fossils appear to preserve animals that died while trying to escape. These interpretations are careful, because sediment can be complicated, but the pattern is hard to ignore. For the animal, there would have been little time. Sand sliding from a dune face can trap the legs first. Movement drives the body deeper. Breathing becomes work. A small theropod might claw upward and only loosen more sediment. A nesting adult could be pinned before it could rise. A mammal inside a collapsing burrow might never reach the surface. The desert's violence was not always loud. Sometimes it was wait. And then, after the wait, stillness, the sun returned. Wind crossed the new surface. Other animals passed nearby, perhaps unaware of the body beneath them. Rain came again, or did not. More sand moved. Layers accumulated. Bones slowly changed into fossil. The event that lasted minutes became part of a rock unit that could hold it for 70 million years. Fossilization is not turning bone directly into stone in one simple step. It is a chemical and physical process, depending on burial, mineral-rich water, time, pressure, and the resistance of hard tissues. In the Gobi, quick burial protected skeletons from scavenging and weathering, while the sediment later hardened around them. The result could be a fossil that preserves anatomy with unusual completeness, even when the animal was small. This is why the Gobi is so important for mammals. Mesozoic mammals are often known from teeth and jaws because those parts preserve best and carry useful anatomical information. But the Gobi has yielded more complete remains, including skulls and skeletons that show posture, limbs, and lifestyle. Some were burrowers, some were agile surface dwellers. They lived under dinosaurs but not as failures. They were specialized survivors. The mammals did not wait knowingly for the asteroid. Evolution does not plan. They simply lived in niches that worked. Small bodies, fur, good hearing, good smell, flexible diets, and burrowing habits helped them in the Cretaceous desert. Much later, some of those same general advantages would help their descendants survive the end Cretaceous catastrophe. But in the Geoducta world, they were just part of the local fauna, as ordinary and as urgent as lizards. The lizards matter too. They are easy to ignore beside a famous fighting fossil, but they help make the ecosystem real. A lizard crossing warm sand, an insect moving under a shrub, a small mammal nosing through the night. a Protoceratops herd shifting toward water. Oviraptorid adults returning to nest sites. Velociraptor watching from cover low enough to hide it. These are not background details. They are the world that made the famous fossils possible. A graveyard without an ecosystem becomes a cabinet of curiosities. The Gobi is more than that. The fossils show repeated patterns of life and death in a dry Cretaceous basin. Herbivores needed plants. Predators needed herbivores, eggs, carcasses, or smaller animals. Nesting species needed safe ground that was not always safe. The same landscape that offered open visibility and warm sand could become a trap when weather shifted. The title Protoceratops and Oviraptor can sound like two dinosaurs placed side by side, but they were part of the same ecological fabric. Protoceratops may have provided eggs, juveniles, carcasses, and competition for space. Oviraptorids nested nearby and probably fed on a varied diet, perhaps including plants, small animals, eggs, or hard-shelled food depending on the species and evidence. Velociraptor threaded through the same system as an active predator and scavenger. None of them existed alone. Oviraptorid diet is not as simple as the old name suggests. Toothless beaks, jaw anatomy, and related specimens point toward flexible feeding, but exact food preferences are difficult to pin down. Some Oviraptorosaurs may have eaten plants, small vertebrates, mollusks, eggs, insects, or a combination. The safest picture is not an egg-obsessed thief, but an adaptable theropod using a beak and hands in a dry environment where opportunity mattered. Adaptability may be the quiet theme of the Gobi. Protoceratops adapted the ceratopsian body plan to a smaller desert herbivore. Oviraptorids adapted theropod anatomy to beaks, nests, and brooding. Velociraptor adapted dromaeosaur tools to hunting in open sand and sparse cover. Mammals adapted by staying small and often hidden. Even the plants adapted to dryness and disturbance. The ecosystem was not lush, but it was not poor. It was selective. Dry environments can produce strong fossil records because bones may not decay as quickly on the surface, but exposure can also destroy them. The key is burial before weathering finishes the work. A carcass left too long in the open will crack, scatter, and vanish. A carcass buried too slowly may be disturbed. The Gobi's exceptional fossils come from the cases where timing was exact enough for preservation and sudden enough to interrupt destruction. Timing is everywhere in these rocks. The moment rain loosens a slope. The moment a nest is covered. The moment two animals cannot separate. The moment an embryo is sealed inside an egg. The moment a fossil emerges from a cliff and begins to weather again after millions of years underground. Paleontology is often the study of timing after the fact. When the Central Asiatic expeditions brought back the first widely recognized dinosaur eggs, they changed public understanding of dinosaurs. Today, dinosaur eggs may seem obvious because birds are living dinosaurs and most reptiles lay eggs, but in the early 20th century, the fossil proof mattered. The flaming cliffs gave paleontology not only skeletons, but reproduction. It confirmed that dinosaurs nested, laid eggs, and left traces of family behavior that could be studied in stone. A nest changes the emotional distance. A skull can feel monumental. A claw can feel dangerous. An egg feels unfinished. It carries a life that did not arrive, a body that remained inside the shell, a future stopped before it had a shape in the world. The Gobi's eggs are not sentimental objects, but they make the animals harder to treat as monsters. They were breeding populations. They had young. They invested in places. Many modern birds arrange eggs carefully, brood them, turn them, shade them, and defend them. Oviraptorids were not modern birds, yet their nests show that some behaviors associated with birds began before birds became fully modern. This is one of the reasons non-avian theropods matter so deeply to evolutionary biology. They show that traits often considered uniquely avian were assembled piece by piece among dinosaurs. feathers, too, entered this story gradually. Feathers did not begin as flight equipment in the simplest version of the evidence. They likely served first in insulation, display, or brooding, then later became involved in aerial movement in some lineages. An oviraptorid with feathered arms spread over a nest would not need to fly for its feathers to matter. They could shade eggs, cover eggs, signal to mates, or help regulate body temperature. The image of a feathered animal in the desert may feel unexpected because modern deserts are often imagined as reptile country with scales and heat and hard surfaces. But feathers are not only for cold. They can insulate against heat, protect skin from sun, and serve behavioral roles. A feathered velociraptor or oviraptorid crossing a dune field is not a contradiction. It is a reminder that the Mesozoic does not have to match modern intuition. Popular memory has not always been kind to these animals. Velociraptor was enlarged and stripped of much of its real context. Oviraptor was branded a thief. Protoceratops was sometimes treated as little more than prey or a stepping stone toward Triceratops. The fossils tell a better story. They show animals at their own scale, in their own environment, with their own pressures and forms of success. Protoceratops was not a primitive mistake waiting for later ceratopsians to improve it. It was successful in its world. Its size suited the environment. Its beak and jaws suited the plants available to it. Its frill may have had roles in display, muscle attachment, species recognition, or a combination of functions. Its abundance suggests a dinosaur that did not merely survive at the edge of the ecosystem, but helped define it. The frill is often treated as decoration, but dinosaur structures rarely fit one category so neatly. In Protoceratops, the frill changed through growth and varied among individuals. It may have been used in display or social signaling. It may have provided attachment area for jaw muscles. It may have helped individuals recognize maturity or status. The fossil record can show shape and growth, but behavior must be inferred from anatomy, comparison, and pattern. Picture two Protoceratops facing each other near a low bank of sand. Their heads tilt, their frills present broad surfaces to one another. They do not need horns to be visually expressive. The beaks open slightly. One shifts its weight. The other steps aside. Maybe this is rivalry. Maybe courtship. Maybe only proximity around food. The fossils do not preserve the exchange, but the skulls preserve the possibility. In many dinosaur species, social behavior is difficult to prove. Trackways, bone beds, growth series, nesting grounds, and repeated associations can all suggest patterns, but none speak with the clarity of a filmed animal. For Protoceratops, the abundance of individuals and age ranges supports the idea that these animals were common and may have gathered, but details of herd structure remain uncertain. It is enough to say that they were part of a populous herbivore community. The more carefully the Gobi is studied, the less empty it becomes. The desert that once seemed like a place of isolated spectacular finds turns into a network of lives. The nest belongs to reproductive behavior. The fighting fossil belongs to predator-prey dynamics. The mammal skeleton belongs to nocturnal or burrowing niches. The sandstone belongs to dunes and rainstorms. Each object points beyond itself. That is what good fossil localities do. They allow paleontologists to move from naming animals toward reconstructing systems. A skull becomes diet. A limb becomes posture. An egg becomes nesting. Sediment becomes climate. A cluster of specimens becomes a death assemblage. When enough lines of evidence overlap, the ancient world gains weight. It remains incomplete, but it becomes structured enough to walk through in the mind. The walk begins in heat. Fine sand underfoot, low ridges of dunes, small plants holding the ground where they can. A shadow passes, not from a pterosaur this time, but from a dust cloud moving along the horizon. Somewhere, a Protoceratops tears at vegetation with a beak. Somewhere else, an Oviraptorid turns its head above a clutch of eggs. The day is ordinary, until it is not. Storms in arid landscapes can be violent because the ground is not prepared to receive water. Rain falls faster than dry sediment can absorb it. Channels form. Slopes fail. A dune that stood all season may suddenly move. For animals near the base of the slope, the event is not climate. It is impact. Sand comes down, and the difference between escape and preservation becomes a matter of seconds. The phrase sandstorm fossil should be heard with that complexity behind it. Windstorms may have buried tracks, shifted dunes, and driven animals to shelter. Rainstorms may have triggered sand avalanches. Dry dune faces may have collapsed under their own instability. What the fossils share is not one cinematic wall of dust, but rapid entombment in a sandy desert system. The exact mechanism varies, but the result is the same: bodies protected from disappearance. At Ukha Tolgod, researchers have described deposits where dune-derived sandslides preserved a rich fauna, including dinosaurs, mammals, and lizards. This kind of geological detail matters because it explains why the fossils look the way they do. A skeleton buried in a river channel may be rolled, broken, or mixed. A skeleton sealed by a sandslide can remain nearly in place, retaining the posture of death and sometimes the evidence of struggle. Some Gobi fossils have been interpreted as animals caught while digging or trying to escape. The posture of limbs, the position of the body, and the surrounding sediment can suggest a final effort against burial. These are difficult interpretations, but they give the desert a frightening immediacy. The animal is not simply dead. It is interrupted. The last movement becomes part of the evidence. There is humility in that evidence. A fossil can be spectacular without telling a complete story. The fighting pair does not tell us all fights. The brooding Oviraptorid does not tell us every nesting behavior. A mass of Protoceratops bones does not reveal every social pattern. The Gobi offers glimpses, and the work is to connect them without forcing them into a single dramatic script. The reference point for the Gobi is often death, but every death implies a life before it. Protoceratops had to hatch, grow, feed, avoid predators, perhaps compete for mates, and survive seasons of scarcity. Oviraptorids had to find food, build or prepare nests, lay eggs, and remain near them long enough for danger to matter. Velociraptor had to hunt often enough to live and fail often enough to leave no trace. Most days were not fossil days. Most days in the Jadakta were probably practical. Animals moved between food and shade, between nest and foraging ground, between burrow and surface. The desert did not require constant drama. It required endurance. Heat had to be managed. Water had to be found. Eggs had to be placed where they would not cook, chill, flood, or be discovered. Predators had to conserve energy because failed hunts are expensive. Dinosaur metabolism in these animals remains a subject of broad scientific discussion, but many theropods were likely more active and physiologically bird-like than older reptilian models suggested. Oviraptorids and dromaeosaurs especially fit into a feathered, active, warm-bodied picture of dinosaur life. Protoceratops, as a ceratopsian herbivore, may have had a different metabolic profile, but it was still an active terrestrial animal in a demanding environment, not a sluggish creature waiting for heat. Behavior leaves different kinds of evidence. Nests show reproduction. Bone surface marks can show feeding, trampling, disease, or injury. Growth lines in bone can indicate age and development. Tooth wear can suggest diet. Sediment around a skeleton can suggest burial. No single clue carries the whole animal, but together they turn fossils into biological evidence rather than static museum objects. The Gobi is one of those rare places where the clues accumulate densely enough to feel almost cinematic without invention. A nest here, a predator and herbivore there, a clutch with embryos, a mammal preserved whole enough to restore its posture, a dune bed that explains the suddenness. The desert writes in fragments, but the fragments are unusually close to scenes. Still, the scenes must remain quiet. A parent on a nest is not a symbol. It is an animal doing the work its body and instincts required. A Protoceratops in a fight is not a hero. It is a herbivore refusing to die easily. A Velociraptor with a broken arm is not a villain. It is a predator caught in the danger that all predators face when prey is alive. Predation is risky. Modern predators fail more often than they succeed, and many are injured by prey. The fighting dinosaur specimen shows that this danger is ancient. A clawed predator did not dominate every encounter. A beaked herbivore could clamp down hard enough to break or trap an arm. The balance between hunter and hunted was not simple. It was negotiated in muscle and pain. Some bite marks and feeding traces from related Gobi deposits suggest Velociraptor and Protoceratops interacted beyond the famous fighting specimen, possibly through scavenging or predation. That is important because one fossil, however dramatic, can be an exception. Additional evidence helps place the interaction inside the food web. It makes the famous fossil less isolated and more biologically plausible. A carcass in the desert would draw attention quickly. Smell carries. Small theropods arrive. Insects arrive. Mammals may visit at night. Lizards investigate. Bones are pulled, marked, exposed. If sand does not cover the body soon, it enters the ordinary economy of decay. That is why a complete skeleton feels almost like a rescue from the normal fate of bodies. In fossil sites, the absence of scavenging can be as meaningful as its presence. Articulated skeletons suggest rapid burial or protected settings. Disarticulated bones suggest exposure, transport, trampling, or repeated disturbance. The Gobi has both, but its reputation rests on the articulated specimens that seem to have been taken from life into sediment with unusual speed. They allow paleontologists to study posture, association, and sometimes behavior. Consider the hands of an Oviraptorid. Long fingers, curved claws, arms folded near a nest. These hands were inherited from theropod ancestors that used forelimbs for grasping prey or manipulating objects. In a nesting context, those same limbs may have helped cover eggs, arrange material, or brace the body above the clutch. Evolution often repurposes structures rather than inventing new ones from nothing. The beak is another repurposed tool. In Protoceratops, it cropped plants. In Oviraptorids, a toothless beak did something more varied and less certain. Beaks are useful because they can be strong, lightweight, and adaptable. Birds would later explore beak diversity on an enormous scale. In the Gobi, before that later radiation, theropods and ceratopsians were already showing different ways a beak could structure a life. The late Cretaceous Gobi was also part of a larger Asian dinosaur record. Other formations nearby, such as the Barungoyot and Nemegt, preserve related but distinct environments, including more humid settings in the Nemegt. The Jadocta represents the drier end of that spectrum, which is why its fossils carry the signature of dunes and sudden sand burial. Regional comparison helps separate local environment from continent-wide dinosaur evolution. In the Nemegt, larger predators and wetter floodplain faunas become more prominent. In the Jadocta, smaller desert animals and exquisite preservation dominate. These differences show that a single region can hold multiple dinosaur worlds across time and environment. The Gobi is not one fossil site. It is a broad archive of changing Cretaceous landscapes. Yet the flaming cliffs remain the emblem because they made the first impression. Red stone. Dinosaur eggs. Protoceratops skeletons. Oviraptor's accusation. Velociraptor's name. The place helped turn dinosaurs from isolated bones into animals with nests, enemies, and environments. It changed what the public thought dinosaurs could leave behind. A museum specimen from the Gobi carries the desert with it, even under glass. The sandstone has been removed, the bones stabilized, the label written. But the posture remains, the curve of the spine, the placement of the jaws, the eggs set in a ring. A visitor sees a fossil. A paleontologist sees an event, a deposit, a field season, a history of interpretation, and the animal itself. The animal itself must remain central. Protoceratops was not famous because it helped explain Velociraptor. Oviraptor was not important only because its name was wrong. These dinosaurs were successful organisms in a specific ecosystem. Their value is not limited to what they teach about more familiar animals. They deserve to be understood on their own terms, as residents of a dry Cretaceous world that asked different things of them. For Protoceratops, those terms included low browsing, strong jaws, growth through vulnerable stages, and perhaps social life shaped by space and scarcity. For oviraptorids, they included nesting, beaks, feathers, flexible diets, and parental association. For Velociraptor, they included agility, predatory risk, feathers, and a body much more elegant than the oversized image that replaced it in popular culture. The Gobi corrects scale. It shows that a dinosaur does not need to be enormous to matter. A sheep-sized herbivore can anchor an ecosystem. A mid-sized theropod can transform our understanding of parenting. A small predator can become one half of the most vivid combat fossil ever found. A mammal smaller than a hand can illuminate the hidden world beneath dinosaur feet. This is partly because smaller animals are closer to behavior in the fossil record. Giant bones impress by size, but nests, eggs, fighting postures, burrows, and intact small skeletons invite questions about daily life. What did they do? How did they move? What did they protect? Where did they sleep? How quickly did the sand arrive? The Gobi keeps returning the question from spectacle to living detail. There is still danger in making the details too certain. A nest does not reveal every parental behavior. A posture does not prove emotion. A bite mark does not always distinguish hunting from scavenging. A dune deposit does not always record the exact weather event. The discipline lies in building a scene that remains honest. The best prehistoric images are made with both imagination and restraint. Restraint does not make the world less vivid. It makes it more believable. A Protoceratops walking under a pale sky with dust on its beak is vivid enough. An oviraptorid settling over eggs while wind moves across the nest is vivid enough. A sand slope beginning to slide behind two struggling animals is vivid enough. The fossils do not need to become legends. They are stronger as evidence. The desert also teaches patience on a geological scale. A bone buried in sand is not immediately a fossil. Minerals move slowly. Sediment compacts. Rock forms. Continents shift. Climate changes. The ancient desert becomes part of a modern desert, exposed again by erosion. The fossil returns to light only because stone that protected it also eventually lets it go. Erosion is the second discovery before humans ever arrive. Wind removes grains. Rain cuts small channels. Frost and heat crack surfaces. A skull begins to weather from a slope. For a while, it is vulnerable again. Too long at the surface, and it will break apart. Found in time, it becomes a specimen. Missed, it becomes sand. Every fossil in a museum is therefore a narrow survivor twice over. It survived death, burial, chemistry, pressure, uplift, erosion, exposure, and the chance of being noticed. The Gobi graveyards feel abundant, but each specimen still passed through an almost impossible filter. That filter is why paleontology must treat every bone as both data and accident. Field crews in the Gobi work under conditions that can be physically demanding. Heat, wind, distance, and limited water all shape the work. Fossils may be jacketed in plaster and carried from remote localities. Notes, maps, photographs, and sediment samples are as important as bones because context gives the specimen meaning. A fossil removed without context loses part of its story. This is especially true for nests and articulated skeletons. The exact position of each egg matters. The orientation of the adult body matters. The relationship between skeleton and bedding matters. Once the specimen is removed, those relationships can only be studied through records. Modern excavation is therefore slow by design. The goal is not simply to collect, but to preserve information that cannot be restored if lost. In the 1920s, methods were different. The expeditions were groundbreaking, but they worked with the tools and assumptions of their time. Some interpretations were wrong, some field details were recorded differently than they would be today. That does not erase their importance. It places them in history, where discovery and limitation sit together. The story of Oviraptor shows this clearly. The original association with eggs was real. The conclusion drawn from it was plausible to the scientists who drew it. Later fossils changed the interpretation. The old specimen did not change. The evidence around it did. That is one of the most important lessons a fossil can teach. A bone may be fixed in stone, while its meaning continues to move. Meaning moved again when feathered dinosaurs became impossible to ignore. A velociraptor, imagined as a scaly desert killer, is not the same animal as a feathered dromaeosaur with bird-like ancestry and complex behavior. The claws remain. The teeth remain. The danger remains. But the texture of the animal changes, and with it, the world around it. A feathered predator in a desert is more interesting than a naked movie monster because it belongs to evolution rather than fantasy. Its feathers link it to thermoregulation, display, and ancestry. Its body links it to birds without making it a bird. Its size links it to real ecological interactions rather than exaggerated spectacle. The real animal is smaller, but the real story is larger. Velociraptor's prey and food sources would have varied. It could have hunted small animals and juveniles, scavenged carcasses, and occasionally attacked larger herbivores under favorable conditions. The fighting dinosaur specimen suggests direct confrontation with Protoceratops, but daily survival likely involved many less dramatic meals. Predators cannot live on rare heroic battles. They live on opportunity. Opportunity in a dry ecosystem includes eggs. It includes carcasses exposed by heat. It includes hatchlings, lizards, mammals, insects, and wounded animals. It also includes risk. An egg clutch might be defended. A carcass might attract competitors. A Protoceratops might bite down. A dune slope might fail beneath predator and prey alike. The desert does not separate opportunity from danger. Near a nest, the ground would hold smells that fossils cannot preserve. Shell, dust, animal skin, perhaps feathers, perhaps plant matter used to line or shape the nesting surface. The eggs would be warm or shaded, depending on the hour. A parent might turn its head toward movement. The scene is simple, and because it is simple, it feels close. We should not assume every oviraptorid parent died heroically defending eggs from a storm. Some may have been brooding when buried. Some may have been near nests for other reasons. Some associations may be disturbed. The famous posture provides strong evidence for brooding in at least some cases, but each specimen must be evaluated on its own. Scientific trust is built specimen by specimen. Even with that caution, the behavior is remarkable. A non-avian dinosaur arranged over a clutch in a posture comparable to brooding birds collapses part of the imagined distance between extinct and living dinosaurs. It does not make the past familiar exactly. It makes the familiar older. Every bird nest becomes, in a quiet way, part of a much deeper pattern. A bird settling over eggs today is not an oviraptorid. It is separated by tens of millions of years. Survival, extinction, and transformation. But the act of covering a clutch, of placing a warm body between embryos in the world, has roots that reach into dinosaur history. The Gobi lets us see one of those roots in red stone. The landscape around those nests had its own rhythms. Morning light would strike the dune slopes at a low angle. Heat would build through the day. Small animals might remain under cover until cooler hours. Herbivores would move when feeding was efficient, and rest when heat made movement costly. Wind would erase tracks almost as soon as they formed, except where moisture briefly held the surface. Trackways are less famous in the Jadocta story than skeletons, but tracks matter wherever they occur because they record movement directly. A footprint is not the body. It is an action. It shows weight applied to ground. In deserts, tracks may be quickly erased or quickly buried. A track surface preserved in sand can reveal animals passing through even when no bones remain. Imagine a line of small prints crossing near a dune base. 3 toes, light pressure, perhaps a theropod moving fast. Nearby, deeper rounded impressions from a heavier herbivore. A drag mark from a tail or belly is unlikely for most dinosaurs, but a slip, a turn, a stumble might appear for a moment. Then, wind moves over the surface, and most of the evidence returns to sand. Bodies are harder to erase when burial comes first. A Protoceratops caught in a sand flow becomes a shape inside the deposit. The head may twist, the limbs may fold, the ribs may remain in order. Later, when the rock is opened, the animal can appear almost too complete. That completeness is not peace. It is the result of death arriving before destruction could scatter the body. This is the paradox of the Gobi. The most violent moments became the most informative ones. The animals preserved best are often the ones denied the ordinary processes that would have returned their bodies to the ecosystem. The graveyard teaches because the grave closed quickly. Yet the ecosystem still depended on ordinary death. Most carcasses would have fed scavengers and decomposers. Most eggs would not become fossils. Most nests would fail or succeed without leaving a trace. The fossil record is an exception drawn from a constant background of consumption. It is important not to confuse what preserved with what was common in every detail. Protoceratops appears common in the Jadocta partly because it was probably genuinely abundant and partly because its bones preserved well under local conditions. Oviraptorid material is rarer but behaviorally rich because of nest associations. Velociraptor is less common, as predators usually are, but its fossils carry unusual interpretive weight. The relative abundance of fossils must always be read through both ecology and preservation. In living ecosystems, herbivores usually outnumber large predators because energy is lost at every step of the food chain. Plants turn sunlight into tissue. Herbivores turn plant tissue into animal tissue. Predators take a smaller share from herbivores. The same broad principle applied in the Cretaceous. A desert with many Protoceratops could support fewer velociraptors, just as modern prey populations support fewer hunters. That means most Protoceratops days did not end in a fight. Most velociraptor hunts did not become fossils. Most oviraptorid nests were not buried with an adult above them. The famous moments survived because they were rare, and because the sediment was ready. In deep time, rarity and preservation can combine to create the images by which entire worlds are remembered. The Gobi's images are unusually strong. A red cliff under low sun. A clutch of eggs that once changed science. A misnamed theropod restored by later evidence. A small horned dinosaur abundant enough to define a formation. A predator and prey locked in a final contest. A sand avalanche acting like a shutter, closing over life and holding it still. But behind the images is work. Preparation under microscopes, comparisons between eggshells, reassessment of old specimens, geological mapping, debates over stratigraphy and age, careful language about what can and cannot be known. The cinematic power of the Gobi exists because the science underneath it is patient. Without that patience, the fossils become stories too easy to tell and too easy to get wrong. Dating the Jadocta and related formations has not always been straightforward. Late Cretaceous desert deposits can lack the marine fossils often used for global correlation, and different localities may not be exactly the same age. Researchers use stratigraphy, magnetostratigraphy, radiometric constraints where available, fossil comparisons, and sedimentological context to refine the timeline. The common age range places many famous Jadocta fossils in the Campanian stage, roughly around the later part of the Cretaceous. The exact number of millions of years matters less for the narration than the order of worlds. This was after the Jurassic. After Archaeopteryx. After many early bird lineages had begun. Before the final extinction at 66 million years ago. In the Gobi, dinosaurs had already been dominant for more than 100 million years. They were not new rulers. They were long-established inhabitants of regional ecosystems shaped by local climate. Long-established does not mean secure. Every egg was uncertain. Every juvenile was vulnerable. Every dry season narrowed the options. Every storm could reshape the ground. A lineage may dominate for millions of years, but an individual still lives hour by hour. Fossils pull the enormous scale of evolution down into the scale of a body. The body of Protoceratops was practical. 4 sturdy limbs, a deep torso, a beaked skull, a frill. It likely moved without haste most of the time, conserving energy and heat, but could respond when threatened. Its world did not reward unnecessary movement. It rewarded awareness, endurance, and the ability to turn sparse plants into muscle and bone. The body of Velociraptor was different in almost every way. Light, narrow, balanced by a stiff tail, armed with claws and teeth. A predator's body is a body of decisions, whether to approach, whether to commit, whether the prey is weak enough, whether the risk is worth the meal. The fighting dinosaurs fossil shows one decision that could not be undone. The body of an Oviraptorid was different again. Beaked, often crested, long-armed, feathered, and tied in the public mind to eggs. Its skeleton does not fit the simple categories of old dinosaur art. It is neither a classic carnivore nor a harmless bird-like creature. It belongs to a more interesting middle ground, where diet, display, reproduction, and ancestry all complicate the image. The skulls of Oviraptorids are especially distinctive. Toothless jaws form a beak. The palate and jaw muscles suggest strong biting in some forms. Cranial crests in relatives such as Citipati may have been used in display, species recognition, or sexual signaling. These animals were visually and behaviorally complex. Their nests are famous, but their anatomy alone would make them remarkable. A crested Oviraptorid moving along the edge of a dune would not look like a mistake between reptile and bird. It would look complete. Its feathers would catch dust, its head would lift and turn with quick attention. Its beak would test the ground, a plant, a small animal, a shell, an egg. The animal would not know it was transitional. It would only know hunger, heat, and the needs of its own body. Transitional fossils are named by those who come later. Archaeopteryx, feathered dinosaurs, Oviraptorids, early birds, all become part of a map drawn backward from the present. In life, there are no transitions, only organisms. The Gobi reminds us of that by giving the animals enough detail to stand on their own, not merely as steps towards something else. Still, the connection to birds is unavoidable and important. Oviraptorid brooding behavior, feathered theropods, and the presence of bird-like features across Maniraptoran dinosaurs all show that many traits associated with birds evolved before the end of the non-avian dinosaur world. A nest at the Flaming Cliffs is therefore also part of the deeper history of every bird that sits on eggs today. This does not mean birds descended from Oviraptor specifically. They did not. Oviraptorids were side branches within the broader theropod radiation. The connection is evolutionary neighborhood, not direct ancestry. But side branches can still reveal what was possible in the broader group. They show shared inheritance and parallel experiments. They help reconstruct the toolkit from which birds emerged. The toolkit included feathers, beaks in some lineages, complex nests, brooding postures, air-filled bones in many theropods, and active bodies. The Cretaceous desert did not look like a modern bird colony, but it held behaviors that modern eyes can recognize in fragments. Recognition is not sameness, it is a bridge. The bridge ends at extinction for most of these animals. Protoceratops would not survive to the present. Oviraptorids would vanish before or at the end of the Cretaceous. Velociraptor would leave no living species. The desert ecosystems changed, and eventually the asteroid impact ended the non-avian dinosaurs everywhere. But extinction did not erase the evidence already buried. The sand kept their bodies after the lineage was gone. That is another reason the Gobi feels haunted. It preserves dinosaurs late in their reign, but before anyone could know the reign was temporary. The animals lived with no sign that a global catastrophe waited in the future. They faced local dangers: drought, predators, nests exposed, dunes collapsing. Their world was ending only in the ordinary way, one individual at a time. Human attention tends to move toward final disasters, but most of life happens before the ending. The Gobi is not a story about the extinction of dinosaurs. It is a story about their living complexity in a time when they were still deeply successful. The graveyards are full of death, but what they reveal is life, reproduction, predation, growth, parental behavior, ecological structure, and adaptation to drylands. To make sense of that life, paleontologists combine multiple sciences. Anatomy identifies the animal, sedimentology reconstructs the environment, taphonomy studies how bodies became fossils, comparative biology uses living animals to frame possible behavior, geochemistry and stratigraphy place the fossils in time. No single discipline owns the story. The Gobi requires all of them. A sedimentologist may look at the same cliff as a dinosaur specialist and see a different first story. Not Protoceratops, but crossbeds. Not Oviraptor, but dune slip faces. Not a graveyard, but a pattern of sand transport, rainfall and burial. Then, the two views meet. The animal explains why the deposit matters emotionally. The deposit explains why the animal survived scientifically. Without the sand, the nest is gone. Without the nest, Oviraptor remains accused. Without the accusation, the correction loses some of its force. Without the correction, the Gobi becomes simpler than it was. Every layer of the story depends on another layer, the way a fossil depends on the rock that hides it. The Gobi also demonstrates how public dinosaur knowledge changes. Generations learned Oviraptor as an egg thief. Later generations learn it as a misunderstood parent or nesting animal. Velociraptor shifted from scaly, oversized hunter to smaller, feathered dromaeosaur. Protoceratops shifted from background herbivore to one of the best windows into ceratopsian growth and desert life. These changes are not failures of science. They are science working through evidence. It is easy to say that old paleontologists were wrong, but a fairer reading is that they reasoned from what they had. The first egg discoveries were unprecedented. The association of Oviraptor with eggs invited a conclusion. The later discovery of embryos and brooding postures supplied evidence unavailable before. Scientific humility means allowing both the old reasoning and the new correction to be visible. The result is a richer animal. Oviraptor as a thief is simple. Oviraptor as a nesting theropod in a desert ecosystem is complex. It has a body, a reproductive strategy, evolutionary relatives, possible feathers, uncertain diet, and a name that preserves an error. Complexity is not less compelling than drama. It is what drama becomes when evidence is allowed to deepen it. Protoceratops has also deepened through study. Growth series show changes in skull shape through life. Comparisons between localities help refine the age and correlation of Gobi strata. Variation in frill and nasal features can be studied against development and taxonomy. These details may sound technical, but they are how paleontology moves from a generic animal to a population with growth, variation, and history. A juvenile skull beside an adult skull is a quiet kind of time machine, the same animal, or at least the same kind of animal, seen at different ages. The frill expands, the proportions change, the jaw strengthens. The young animal that might have been easy prey becomes an adult able to meet a predator with force. Growth is one of the oldest survival strategies on Earth. Not all reached that adult strength. Predators would have watched the young. Eggs would have been vulnerable to temperature, burial, and animals with beaks or teeth. Hatchlings would have faced heat, hunger, and quick hunters. A successful species is built on many individual failures. The fossil record rarely preserves enough to count them, but the logic of life requires them. Nesting in an arid environment involves trade-offs. Eggs need gas exchange, stable temperature, and protection from predators. Burying eggs can help regulate humidity and temperature, but too much burial can suffocate embryos. Exposing eggs can allow brooding and ventilation, but increases vulnerability. The ring-shaped oviraptorid clutches suggest a reproductive method tuned to body posture and environmental conditions, not a random scattering of eggs. The center of an oviraptorid clutch is especially interesting. In some nests, eggs form an outer ring with a space where the adult could sit. The adult's weight would be placed away from the eggs, while arms or feathers could cover the clutch. The geometry turns behavior into a fossil pattern. You can read the body even when the body is gone. In the best cases, the body is not gone. It remains above the eggs, folded and fixed. The head may be missing or crushed. The limbs may be distorted. The posture may still be unmistakable. A theropod over a nest in the Gobi is one of those images where the distance between paleontology and life becomes very small. That small distance is not the same as certainty. We do not know what the animal felt or whether it had any experience comparable to what humans would call care. We do not need to know. Behavior can be important without being sentimentalized. A crocodile guarding a nest, a bird brooding eggs, an oviraptorid positioned over a clutch, all belong to the broader biological problem of reproduction under risk. Reproduction under risk shaped the entire ecosystem. Protoceratops had to produce enough young for some to survive. Velociraptor had to reproduce while living as a predator in a dangerous environment. Oviraptorids nested on exposed or semi-exposed ground. Mammals likely used burrows and hidden spaces. Each lineage solved the problem differently, and the desert tested those solutions. The Gobi's fossils are therefore not only grave markers, they are records of solutions. A beak is a solution. A frill is a solution. A sickle claw is a solution. A ring of eggs is a solution. A burrow is a solution. A dune collapse is not a solution for the animal, but for paleontology it becomes the accident that lets us see the others. The Jadakta Formation is sometimes described as preserving a fauna similar in some ways to the modern Gobi's harsh desert-adapted communities, but it is important not to overstate the comparison. The ancient climate, plants, and animals were different. There were no grasses like modern steppe grasslands in the way we know them today. Flowering plants were present by the late Cretaceous globally, but the local vegetation in these deposits is less completely known than the animals. The safest picture is dry, sandy, and vegetated enough to support herbivorous dinosaurs. Plant fossils are often less spectacular here than dinosaur skeletons, which means the vegetation must be reconstructed from limited remains, sediment, climate interpretation, and comparison with related deposits. We should imagine shrubs, low plants, and patches of tougher vegetation, rather than endless barren dunes. Protoceratops could not live in a landscape with no food. The desert had to feed its animals, even if it did so unevenly. Uneven food creates movement. A herd or loose group moves from one patch to another, heads lower, beaks cut. Dust clings to the mouth. Young animals stay close to adults or drift and are corrected by circumstance. The landscape is open enough that danger can be seen, but also open enough that there are few places to hide. Survival becomes a matter of distance. For a predator, distance is calculation. Too far and the prey escapes. Too close and the prey bites, kicks, or turns. A velociraptor approaching a protoceratops would not simply leap because it was a predator. It would need timing. It would need angle. It would need the herbivore to make a mistake or to already be trapped, young, weakened, or distracted. Predation is not confidence. it is risk management. The famous fossil may preserve the moment risk management failed for both. The Velociraptor got close enough to strike. The Protoceratops got close enough to seize the arm. Then sand ended the calculation. This is why the specimen is not simply a fight. It is a frozen failure of escape for predator and prey alike. In modern fossil interpretation, researchers often examine such specimens through taphonomy as much as behavior. Were the bodies buried where they died? Were they transported? Did the sediment collapse? Were they exposed before burial? The fighting pair's articulation and entanglement strongly suggest the animals were buried in close association, but the exact burial event remains debated. Sand avalanche is a leading explanation because it fits the desert deposits and rapid entombment. The debate does not lessen the fossil, it keeps it alive scientifically. A specimen that can still be questioned is still producing knowledge. The Gobi's most famous fossils are not finished relics, they are active evidence, returned to whenever new methods or new comparisons make old details visible again. That may be the deepest reason this place holds attention. It is not only ancient, it is unfinished. The rocks have yielded enough to create iconic stories, but not enough to close them. We know Oviraptor was misjudged, but not everything about its diet. We know Protoceratops was common, but not exactly how it organized its social life. We know sand buried animals quickly, but not every storm or slope that did it. The unknowns should not be treated as gaps to hide. They are part of the voice of the fossil record. A good reconstruction can say probably, may have, suggests, and still remain compelling. The ancient world becomes more believable when uncertainty is allowed to remain visible, like the edge of a bone still disappearing into rock. The Gobi is a place where edges matter. The edge of a dune, the edge of a nest, the edge of a skull emerging from sandstone, the edge between theft and parenting, between predator and prey, between ordinary death and preservation. Paleontology works along those edges, carefully widening them until a world begins to show. The world that shows is late Cretaceous, not Jurassic, despite the channel name and the broader fascination with the dinosaur age, one uncovered surface at a time. It belongs to the final third of dinosaur dominance, when many lineages had already become highly specialized. Ceratopsians were diversifying. Theropods included feathered predators and bird relatives. Oviraptorosaurs had evolved striking skulls and nesting behaviors. Mammals remained small but varied. This was not an early experiment. It was a mature dinosaur ecosystem. Mature ecosystems can still be fragile at the scale of individuals. A dry season stretches too long. A nest is placed too near an unstable slope. A predator chooses prey that fights harder than expected. A storm arrives at the wrong hour. The system continues, but the individual becomes fossil. Deep time is built from these small endings. The graveyards are not moral places. The sand does not punish thieves or reward parents. It does not choose dramatic scenes for us. It follows gravity, wind, water, and sediment. The meanings come later, when humans uncover the bones and try to understand what kind of life was interrupted. That separation matters. Nature made the fossils. We make the stories, and the stories must answer to the fossils. The first answer was that Oviraptor stole Protoceratops' eggs. The later answer was that Oviraptorids were nesting animals, and the eggs likely belonged to them or close relatives. The first answer about the fighting dinosaurs was that predator and prey were locked in combat. That remains broadly supported, but the cause of burial, the exact beginning of the fight, and the final advantage remain uncertain. The answers become stronger when they become more precise. Precision can be surprisingly beautiful. The blunt end of an egg pointing inward. A forelimb placed around the nest perimeter. A claw embedded near a throat. A beak clamped around an arm. Cross-bedded sandstone around a skeleton. These are not vague symbols. They are details. In paleontology, detail is where wonder becomes durable. A child looking at a dinosaur egg may see only the wonder. A researcher sees the pores, the shell layers, the association, the matrix, the history of mistaken assignment. Both views matter. The first keeps the past emotionally alive. The second keeps it honest. The Gobi has always needed both. Roy Chapman Andrews understood the emotional power of the desert discoveries, and the public did too. Dinosaur eggs made headlines because they gave dinosaurs a beginning, not just an ending. Skeletons showed death. Eggs showed reproduction. Together, they made dinosaurs feel like living animals with generations, nests, and vulnerable young. That was a major shift in how prehistoric life could be imagined. The public story often compresses the field story. It may say the first dinosaur eggs were found at the Flaming Cliffs, but the full history of eggs and eggshell discoveries is more complicated. What the Gobi provided was the first widely recognized, scientifically celebrated discovery of dinosaur eggs in nests tied to major expeditions and later to famous controversies about parentage. Its role in public and scientific history is beyond dispute even when the details are nuanced. The eggs are still powerful because they are ordinary biological objects made extraordinary by time. Every egg is a temporary structure. It is meant to be broken by the animal inside or lost if development fails. A fossil egg reverses that destiny. The shell does not open. The temporary becomes permanent. The future remains closed and visible. In some eggs, embryos preserve enough to identify the kind of dinosaur inside. Those are among the rarest finds because embryos are delicate, and eggs can be crushed, weathered, or mineralized in ways that destroy internal detail. When an embryo survives, it can overturn assumptions more effectively than any argument. The tiny bones inside the shell speak for the parent more clearly than proximity alone. That is what happened with the Oviraptor story. Identical or closely similar eggs with oviraptorid embryos showed that the eggs once assigned to Protoceratops could belong to oviraptorids. Brooding adults reinforced the point. The interpretation changed because multiple independent lines of evidence converged: egg structure, embryo identity, adult posture, and nest arrangement. This convergence is why the modern view is so strong. Oviraptor Velociraptor itself remains known from limited material, and much of what people imagine when they picture Oviraptor may come from better-known relatives. This is common in paleontology. A famous name can stand in for a family of animals because the type specimen is incomplete, while relatives preserve more anatomical detail. Careful narration should distinguish Oviraptor from oviraptorids, while still explaining why the name became central. The name became central because it captured a human judgment. Egg thief is a story, not just a label. It assigns motive to bones. Later evidence did not simply correct a diet, it corrected a character. The animal did not deserve the accusation, but it keeps the name, because scientific names, once established, do not change just because the story behind them does. There is an odd tenderness in that. A dinosaur named for a theft it probably was not committing, preserved near the thing that revealed something closer to care. The fossil does not ask for sympathy. It simply lies there, and the evidence changes around it until the name becomes a reminder to be careful. Care is not the same as kindness in nature. A brooding animal may still be dangerous. An oviraptorid could guard a nest and eat other animals. A velociraptor could be feathered and still kill. A protoceratops could be a plant eater and still break a predator's arm. The Gobi resists simple categories: parent, predator, prey, scavenger, survivor. In real ecosystems, animals can occupy several of these meanings across a lifetime. A protoceratops carcass might feed a velociraptor. A velociraptor carcass might feed insects and mammals. An abandoned nest might feed small animals. A successful nest might produce young that become prey or adults. The ecosystem is not a set of roles assigned permanently, but a circulation of matter through bodies. The graveyard is what remains after that circulation was interrupted. In the fossil record, interruption can be more visible than continuity. A nest buried before hatching is visible. A nest that hatched successfully may leave broken eggshell, or nothing at all. A fight buried in progress is visible. 100 avoided fights leave no fossil. A predator's failed approach, a herbivore's warning call, a parent shifting shade over eggs, most behavior disappears. The Gobi's gift is not that it preserved everything, but that it preserved enough exceptions. Enough exceptions can change a whole field. They can teach that dinosaurs laid eggs in organized nests. They can show that non-avian dinosaurs brooded. They can preserve direct physical interaction between predator and prey. They can reveal small mammals with bodies more complete than teeth alone. They can make a dry desert one of the richest places in the study of ancient life. Richness in the Gobi is not lushness, it is concentration. It is the density of evidence in rock. A person walking the modern surface may see miles of bare ground, but beneath that ground are layers where ancient events accumulated. The desert looks open because vegetation is sparse. The fossil record feels full because the sediment did unusual work. The flaming cliffs at sunset make the connection almost unavoidable. The same red that draws travelers and photographers is the color of the rock that held dinosaur eggs. The cliff face glows, and for a moment the name feels less like a label than a description of time exposed. Fire-colored stone, not burning now, but carrying the heat of an ancient desert and the brief heat of lives inside it. Fossil localities are not static monuments. They erode, weather, and sometimes suffer damage from illegal collecting or unregulated trade. Gobi fossils, especially spectacular dinosaurs and eggs, have been targets for smuggling. Protecting them matters because a fossil taken without scientific context loses information, and because these specimens belong to the country and people whose natural heritage they represent. Preservation is ethical as well as scientific. A fossil egg sold as an object may still look beautiful, but without locality, layer, orientation, and association, it is a sentence cut from its paragraph. It can no longer answer many of the questions it might have answered. Scientific value depends on context. The Gobi's future discoveries will matter most when they are found, documented, studied, and curated with that context intact. This is why museums and field institutions increasingly emphasize collaboration, local stewardship, and repatriation where appropriate. The old expedition model, in which fossils moved one way from distant lands to foreign museums, no longer fits modern paleontology. The Gobi is not only a source of specimens, it is a living scientific landscape within Mongolia, and its fossils are part of Mongolian history as well as Earth history. The rocks themselves do not know these human questions. They weather in the same wind, but the way we treat them has changed, and that change matters. A bone can teach anatomy. A fossil site can teach responsibility. The deep past is not harmed by being handled carefully. It is made more available to the future. The future will almost certainly change parts of this story again. New embryos may refine egg assignments. New skeletons may clarify Oviraptor's anatomy. New sediment studies may distinguish dune collapse from storm burial with greater precision. New Protoceratops specimens may reveal more about growth, variation, and social behavior. The Gobi has already overturned one famous interpretation. It may overturn others. That possibility should not make the current story feel unstable. It should make it feel alive. Science is not a monument built once. It is closer to an excavation, where each layer removed changes the view of the layer below. The best supported conclusions stand because many lines of evidence hold them up, but even they remain open to refinement. This is how knowledge survives. What remains constant is the physicality of the fossils. The eggs are there, the skeletons are there, the sandstone is there, the fighting dinosaurs are there. A fossil does not need to be fully understood to be real. Interpretation changes around the object, but the object continues to demand explanation. That demand is what keeps paleontology moving. Return to the cliff face. The sun is lower now. Shadows gather under ledges. A small bone fragment in the slope could be nothing, or it could be the first sign of an animal last seen in the Cretaceous. Fieldwork often begins with that uncertainty. The hand pauses. The brush comes out. The desert is asked, gently, what it has exposed. If the fragment belongs to Protoceratops, it may lead to a skull with a beak and frill. If it belongs to an Oviraptorid, it may lead to a delicate theropod body, perhaps near eggs. If it belongs to Velociraptor, it may be a tooth, a claw, a limb bone, evidence of a predator that was both smaller and more fascinating than its legend. If it belongs to a mammal, the fragment may be almost impossibly small and still important. Identification depends on anatomy. Ceratopsian skull bones have different shapes from theropod bones. Teeth differ. Limb proportions differ. Eggshell texture and microstructure differ. Paleontologists compare new fragments with known specimens, noting features that diagnose a group or species. The work can be slow, especially when fossils are incomplete, but small differences carry large meaning. A tooth can name a predator. An eggshell can rewrite a nesting story. A claw can carry a whole public imagination, even when the real animal is more restrained than the myth. In deep time, small evidence often bears heavy weight. The Gobi's greatness lies partly in how often it gives evidence small enough to be intimate and clear enough to matter. The desert also keeps silence around what it cannot give. No color of Protoceratops skin is certain. No call of Oviraptor remains in the air. No exact pattern of Velociraptor feathers lies preserved from the Jaducta, in the way some other deposits preserve feather impressions. The animals must be restored with caution, borrowing from relatives, anatomy, and ecology, without pretending the missing details are known. Some reconstructions give Velociraptor a full covering of feathers because close relatives preserve feather evidence and because forearm quill knobs have been reported in Velociraptor. That makes a feathered restoration scientifically reasonable. Exact colors, display patterns, and soft tissue outlines remain unknown. The same applies to Oviraptorids. Feathers are likely in many forms, but details vary and must be inferred. Unknown color does not make the animal gray. It makes the color unconfirmed. The living Gobi dinosaurs may have carried patterns for camouflage, display, species recognition, or sexual signaling. They may have looked stranger and more vivid than conservative reconstructions allow, or they may have matched the sand so well that only movement gave them away. The truth is gone, but the range of possibility is not empty. Skin, feathers, and color rarely fossilize, but behavior sometimes does through position. That is why the Gobi is so valuable. It may not preserve every surface detail, but it preserves relationships: adult to eggs, predator to prey, body to dune, small mammal to burrow, like sediment. Relationships are the grammar of an ecosystem. They tell us not only what the nouns were, but how they acted on one another. In the fighting dinosaurs, the grammar is direct. Claw against throat, beak against arm, sand against both. It is one of the clearest sentences the fossil record has ever written, and still we translate it cautiously. The danger of a clear fossil is that it tempts us to add more than it says. The discipline is to let the sentence remain powerful without completing every clause. In the nesting fossils, the grammar is different. Body above eggs, limbs around clutch, shells arranged with order, sand above body. The sentence is not about violence, but persistence. It is about the way reproduction makes animals stay in dangerous places. To nest is to commit to a site, and the Gobi sometimes punished that commitment with burial. The graveyards also speak to landscape stability. Dunes are mobile, but not every dune moves constantly. Some surfaces may be stabilized temporarily by moisture, vegetation, or crusts. Animals could travel across them, nest near them, or use interdune areas. Then conditions changed. Wind cut the surface. Rain weakened it. Gravity completed the work. The environment was not chaos, but it was never fixed. That instability may explain why certain fossils are so complete. A stable environment allows life to gather. An unstable moment buries it. The combination is rare and productive for paleontology. Too stable, and bodies decay on the surface. Too chaotic, and bones are destroyed or transported. The Gobi's best fossils come from the boundary where life could exist and burial could happen quickly. This is different from classic river bone beds, where floods may transport bones and mix individuals. In Aeolian and dune-related deposits, skeletons can remain closer to where the animal died. That does not make every interpretation simple, but it improves the chance that body position and association reflect real behavior or immediate circumstances. This is why the Jadakta has yielded such memorable specimens. The sand did not preserve intention, but it preserved arrangement. Arrangement is enough to begin. A ring of eggs does not tell us every detail of brooding, but it tells us the eggs were not random. Two bodies locked together do not tell us the entire fight, but they tell us the animals met with force. A folded skeleton in dune sand does not tell us every second, but it tells us the burial was fast enough to matter. Begin with a Protoceratops standing in the lee of a dune. The animal lowers its head and bites at a tough plant. Its frill casts a short shadow across its neck. A juvenile follows near its flank. The air is dry enough that every step lifts dust. Somewhere beyond the next ridge, a Velociraptor watches, not as a monster, but as an animal weighing hunger against danger. Begin with an Oviraptorid at a nest. The eggs are arranged before the storm, before the slide, before the fossil. The adult adjusts its body. It has done this before, or instinct has arranged the action through generations of success and failure. There is no need to imagine tenderness in a human way. The behavior is older than language and strong enough to be recorded in stone. Begin with the slope. Sand grains balanced at the angle of rest. Water enters from rain. Weight changes. Friction fails. A sheet of sediment starts to move. The event may last seconds. It may begin quietly, then gather force. For the animal below it, the distinction between weather and geology disappears. The landscape becomes the predator. Then begin again 70 million years later, with a fossil emerging from the modern cliff. The same slope that buried the animal now releases it. Wind and weather cut away the rock. A scientist sees a shape. A brush exposes a curve. The past returns, not alive, but legible. The graveyard opens one bone at a time. Legibility is the work. The fossil must be mapped, stabilized, prepared, compared, described, and interpreted. Preparation may take months or years. Tiny bones require patience under magnification. Eggs must be supported so they do not crumble. A spectacular fossil can be damaged by haste. The public sees the mount or the photograph. The science happens in the slow middle. That slow middle is where errors are corrected. Oviraptor's story changed because researchers studied eggs and embryos, not because the old names suddenly felt unfair. Brooding behavior became plausible because posture, egg arrangement, and comparison with birds supported it. Sand avalanche interpretations depend on sediment, not only drama. Every important claim has to pass through the slow middle. The slow middle also makes room for ordinary specimens. Not every fossil becomes famous. A partial jaw, an isolated limb bone, a small eggshell sample, a fragment of lizard skull, a mammal tooth, these may not appear in public exhibits, but they build the database from which broader patterns emerge. The famous fossils stand on a foundation of quieter ones. A single mammal jaw from the Gobi may not draw a crowd, but it can show tooth replacement, diet, relationships, or the timing of mammal evolution. A lizard skull can reveal diversity in dry Cretaceous habitats. A small theropod bone can show that the predator guild included more than Velociraptor. The desert's grandeur is partly microscopic. This is a useful correction to the way dinosaurs are often imagined. The Mesozoic was not a stage where only the largest animals mattered. It was full of scales, embryos inside eggs, insects in sand, mammals under cover, juvenile dinosaurs, adults, predators, plants, dunes, basins, continents. The Gobi compresses those scales into localities small enough to excavate and large enough to change science. The term dinosaur graveyard can include several types of fossil concentration. Some are bone beds with many individuals, some are nesting sites, some are localities with repeated articulated skeletons from similar burial processes. The Gobi's reputation comes from all of these together. It is a graveyard in the broad sense, a region where death, burial, and exposure repeatedly aligned to preserve a community. Death aligned with burial, but burial aligned with future erosion. Without erosion, the fossils would still be hidden. Without fieldwork, erosion would destroy them. The graveyard is not a permanent vault. It is a window that opens and closes. Every fossil exposed at the surface is already entering a new phase of danger. Maybe that is why the red cliffs feel alive in their own slow way. They are not still. They are releasing, grain by grain, what they once held. A skull comes out. An egg comes out. A claw comes out. Each appears briefly on the surface before human hands either save it or the desert takes it back. In that sense, paleontology is a race conducted at two speeds. The rocks move slowly over millions of years, then quickly enough to destroy a specimen in a few seasons once it is exposed. The field crew moves with human urgency inside geological patience. The fossil has waited long enough, but once visible, it cannot wait forever. The Gobi has produced fossils for more than a century of scientific study, and it remains productive because the basin is large, the formations extensive, and the erosion ongoing. But productivity does not mean endlessness. Fossil sites can be depleted, damaged, or stripped of context. Sustainable research depends on documentation, protection, and training new generations of scientists who can read the desert with both skill and care. What they read is one of the most complete portraits of a dry dinosaur ecosystem anywhere on Earth. Not complete in the absolute sense, but complete enough to show nests, eggs, growth, predation, small vertebrates, dune burial, and changing interpretation across generations. The Gobi is not merely a place where dinosaurs died. It is a place where the dinosaur age became more behavioral, more ecological, and more intimate. The intimacy comes from scale. Protoceratops is large enough to be unmistakably dinosaurian, but small enough to imagine whole. Oviraptorids are strange enough to feel ancient, but bird-like enough to feel connected. Velociraptor is dangerous enough to hold attention, but small enough that its fights were uncertain. Eggs are small enough to fit in the mind. The desert brings the Mesozoic down from giants to bodies. Bodies leave posture. Posture leaves questions. Questions lead back to the field. That rhythm has defined the Gobi since the first major expeditions and continues today. A fossil is found. A story is proposed. A new fossil complicates it. The story changes. The desert remains, holding more evidence than any one generation can finish. The most famous correction, Oviraptor's reputation, is now a standard example of why fossil association must be interpreted carefully. Two things found close together are related in some way, but not always in the first way imagined. A skeleton near eggs may be a predator, a parent, a scavenger, a victim of the same burial event, or a combination depending on details. Context decides. In the case of Oviraptorids, the details now favor nesting and brooding for several specimens. Adults positioned on nests, egg arrangement, and embryos point toward reproductive behavior. That does not mean every egg in every Gobi clutch belongs to Oviraptor specifically. It means the old assumption that the eggs were Protoceratops eggs stolen by a predator is no longer the best explanation. What happens to Protoceratops in that correction? It loses some eggs that were once assigned to it, but it gains clarity. Instead of being the automatic answer to every egg at the flaming cliffs, it becomes one animal among several nesting and living in the same ecosystem. Its importance does not depend on owning those eggs. Its own fossils are abundant and revealing enough. The correction also changes the moral temperature of the story. A thief killed in the act is a simple fable. A parent buried over eggs is a more complicated biological event. Science does not need moral temperature, but audiences often bring it. The Gobi teaches that the emotional story should follow the evidence, not lead it. Evidence leads us back to sand. Red sand, pale sand, cross-bedded sand, sand hardened into rock. Sand in the eye of an animal, sand around an egg, sand under the foot of a field worker. The same material moves through the story in different forms: environment, hazard, preservative, archive. The sand's origin and movement can be studied through grain size, sorting, sedimentary structures, and the shape of beds. Aeolian deposits tend to have well-sorted grains and crossbedding formed by migrating dunes. Intervals with mud or other sediment can indicate water influence. Together, these features reconstruct a landscape where wind was dominant, but water periodically intervened. That combination is central to many burial scenarios. A purely dry dune might not bury an animal deeply enough at the right moment. A purely wet river system might scatter bones or mix bodies. A semi-arid dune field with occasional intense rain can do both life and death in unusual sequence. It can support animals around temporary resources, then bury them suddenly when storms destabilize the sand. The fossils are products of that sequence. Temporary water would have mattered intensely. A pond after rain, damp sand holding tracks, plants greening in low areas, herbivores arriving, predators following, insects multiplying. Then evaporation, concentration, stress. The landscape would pulse rather than remain constant, and animals would learn its timing through instinct, memory, or movement. We often imagine ancient ecosystems as scenes, but they were schedules: times of day, times of season, times of drought, times when nests were laid, times when young hatched, times when predators hunted more successfully because prey gathered near water. The Gobi graveyards preserve moments from those schedules, especially when the schedule broke. One broken moment was enough to preserve the fighting dinosaurs. Another was enough to preserve an adult over eggs. Countless others left no trace. The fossil record is not a continuous film. It is a series of still frames, most of them missing, some blurred, a few so sharp they seem almost impossible. The sharp frames from the Gobi have shaped dinosaur science far beyond Mongolia. They contributed to the study of dinosaur reproduction, theropod behavior, ceratopsian growth, dromaeosaur predation, Mesozoic mammals, and desert taphonomy. They also shaped public imagination, sometimes accurately, and sometimes through myths that later needed correction. Few fossil regions have done both so strongly. Public myths are not harmless when they replace the animal. Oviraptor as thief, Velociraptor as oversized monster, Protoceratops as passive victim, each loses something. The real animals are more constrained and more interesting. They do not need exaggeration. The Gobi already gives them enough drama through evidence. A real Velociraptor, feathered and low to the ground, is enough. A real Protoceratops, beaked and strong, is enough. A real Oviraptorid over eggs, caught by sand, is enough. The desert does not ask us to make the dinosaurs larger than life. It asks us to let life be large enough. If we follow one day in this ancient desert, we might begin before sunrise. The air is cooler. Small mammals move while shadows still cover the sand. A lizard emerges slowly, waiting for warmth. An Oviraptorid shifts above a nest. Farther away, Protoceratops bodies are dark shapes near low vegetation. The world is not silent, but its sounds are lost. Footfalls, beaks on stems, breath, warning calls, wind. As light strengthens, the sand warms. Small animals retreat or change activity. Protoceratops feed more actively before heat peaks. A young one wanders too far and is pressed back by movement from an adult, or perhaps by the sight of a predator. The oviraptorid leaves the nest briefly or stays, depending on temperature and risk. Each action is ordinary. None knows the day might become a fossil. By midday, heat shapes behavior. Animals seek shade where the landscape offers it. Open dunes become costly to cross. Predators conserve energy. A velociraptor may rest in the shadow of a low slope or vegetation patch, panting or holding its mouth open to shed heat if its physiology allowed similar behavior. The details are uncertain, but the principle is clear. Heat is not background in a desert, it is an ecological force. Later, clouds build. Rain in a dry landscape can be brief and hard. Drops strike loose sand, darkening it. The scent of wet dust rises. Animals respond in different ways. Some seek shelter, some move toward water, some remain on nests because eggs cannot be abandoned safely. The dunes absorb what they can. Then a slope begins to give. The first movement may be small. A narrow sheet of sand slips downward. Then, more follows. If an animal is above it, the ground drops. If an animal is below it, the slope arrives. A fight, a nest, a burrow, a resting body, any of them can be caught in the same mechanical event. The sand does not know what it buries. Afterward, the surface looks changed, but not extraordinary. A fresh apron of sediment at the dune base. Tracks erased. A nest gone. Perhaps other animals avoid the area briefly, or perhaps they return as soon as the storm passes. The fossil is already forming in the sense that the body has been removed from ordinary destruction. The rest will take more time than any living thing can feel. Night returns. The desert cools. Small mammals come out again over ground that now hides a dinosaur. A lizard crosses above a clutch of eggs that will never hatch. Wind moves grains across the new surface. The world continues without ceremony. Fossils begin in that lack of ceremony. Millions of years later, the ceremony is ours. We name the animals. We reconstruct the posture. We compare the eggs. We photograph the cliff at sunset. We stand in museums before skeletons that once lay under sand, and we feel the distance between our world and theirs collapse for a moment. The fossils do not come alive, but they become present. Presence is not the same as completeness. A mounted specimen may hide missing bones with casts. A reconstruction may choose a feather pattern without direct evidence. A museum label may compress decades of debate into a few lines. Good interpretation should invite curiosity rather than close it. The Gobi is best understood as a set of questions made unusually visible. Those questions include how Protoceratops populations varied between localities, how many Oviraptorid species nested in similar ways, exactly how dune collapses occurred, and how desert ecosystems shifted through the Campanian stage. They include the relationship between the Geodacta and nearby formations, the timing of faunal turnover, and the degree to which animals moved between basins. The famous fossils are entry points, not endpoints. An entry point can be a single egg. It can be the wrong name of a dinosaur. It can be a fight. It can be the color of a cliff. The Gobi offers all of these, which is why its story resists narrowing. It is about Protoceratops, Oviraptor, and Sandstorm fossils, but also about how a desert can preserve behavior and how science can change its mind without losing wonder. Wonder that cannot change becomes fragile. The Gobi's wonder has changed many times and become stronger. The eggs are still remarkable, even though many were reassigned. Oviraptor is still famous, even though its name misleads. Velociraptor is still dangerous, even though it was smaller and feathered. Protoceratops is still central, even without being the owner of every nest. The animals are better for being corrected. They return from caricature to biology. Biology is quieter than myth, but deeper. It includes digestion, growth, temperature, reproduction, injury, failed hunts, seasonal stress, and the slow pressure of environment. It makes dinosaurs real enough to die in ways that leave evidence. What did Protoceratops do when the wind strengthened? Did adults turn away and lower their heads? Did juveniles press closer? Did dust collect along the edge of the frill? What did an oviraptorid do when rain began over a nest? Did it rise or settle lower? What did Velociraptor avoid more often than it attacked? The fossils cannot answer all of this, but they make the questions legitimate. Legitimacy matters because imagination without evidence drifts. Evidence without imagination dries out. The Gobi asks for both. The sand, eggs, bones, and postures provide anchors. The living scenes form around them carefully, never pretending to be footage, but never reducing the animals to diagrams. A diagram can show the arrangement of eggs. A scene can show why arrangement matters. A measurement can show the size of Protoceratops. A scene can show the animal lowering its beak to plants. A description can state that Velociraptor was feathered and smaller than film versions. A scene can restore the danger of an animal that does not need to be enlarged. In documentary storytelling, the Gobi should not be treated as a monster arena. The most important stories here are not battles alone. They are nesting, misinterpretation, burial, preservation, and ecological texture. The fighting dinosaurs deserve attention because they are extraordinary, but they should not swallow the whole world around them. A fossil fight is meaningful because ordinary life existed before it. The same applies to Oviraptor. The old egg thief story is useful only as a doorway into a better understanding of oviraptorid reproduction. It should not remain the center after it has been corrected. The corrected story is richer, a group of theropods with beaks, feathers, nests, arranged eggs, brooding postures, and evolutionary links to bird-like behavior. A corrected story also changes the ending of the individual. The animal over the nest no longer dies as a cartoon thief. It dies as part of the reproductive life of its species, in contact with eggs that may have been its own or those of a close relative. Sand covers the body. The future under it closes. The fossil opens a different future, one of knowledge. Knowledge can be a kind of delayed hatching. The egg never opened in the Cretaceous, but millions of years later, the shell opened a scientific question. The animal inside, if preserved, could identify a parent. The nest could change a name. The desert could bring forward a behavior no one had seen directly. What failed biologically succeeded as evidence. That metaphor should not be pushed too far. The embryo did not live. The nest did not complete its purpose. The adult did not survive. Fossils often teach because life ended. It is important to let that fact remain plain. The beauty of the Gobi is not that death becomes meaningful for the animals, but that it becomes informative for us. Informative death is the foundation of paleontology. We study ancient life through ancient endings. A track is an exception because it records life without death, but most fossils are bodies. The Gobi's special contribution is that some of those bodies remain close to behavior. They died while doing something, or near something, or with another animal, and that proximity survived. Proximity is often the beginning of interpretation. The adult near eggs, the predator near prey, the embryo inside shell, the skeleton within a sandslide, the small mammal in a deposit full of dinosaurs. Each proximity asks whether the association is biological, geological, accidental, or all three. Paleontology becomes the art of deciding which kind of closeness matters. In the fighting dinosaurs, closeness is undeniable. The bodies are not merely near, they are engaged. The Velociraptor's limb and claw, the Protoceratops' beak and body, the injuries and positions all point toward interaction at the moment of burial. This kind of evidence is so rare that that it can distort our sense of the past if we forget its rarity. It is a window, not the whole house. Look through the window, though, and the scene is unforgettable. Sand around two bodies. One built to kill, one built to resist. Neither large by dinosaur standards, both large enough to fill the final seconds with force. Then, darkness under sediment. Elsewhere in the same ancient region, less famous animals were also being caught. A mammal in its shelter. A lizard under a small collapse. A young dinosaur near a dune. These fossils do not carry the same public drama, but they are part of the same preservation system. The graveyard belongs to the whole community, not only to its icons. Community is the key word. The Gobi's dinosaurs are often named individually, but their meaning comes from the community. Protoceratops without predators is incomplete. Oviraptorids without nests are incomplete. Velociraptor without prey and scavenging opportunities is incomplete. Mammals without dinosaur-dominated surroundings are incomplete. The desert itself connects them by forcing all of them to solve the problems of dryness, heat, mobility, and sudden burial. A community also includes plants. Even when plant fossils are less abundant, herbivores prove that primary productivity existed. Protoceratops could not be common without food. Oviraptorids, even if omnivorous, depended on the broader food web. Insects depended on plants and detritus. Mammals depended on insects, seeds, or other small resources. The fossil animals imply a vegetated landscape more complex than bare sand. Perhaps low shrubs grew in sheltered areas. Perhaps tougher plants clustered where moisture lingered. Perhaps seasonal growth followed rain. The exact composition is difficult to restore, but the pattern can be felt. Food in patches, shade in patches, water in patches. A patchy landscape creates movement, conflict, and memory. Animals learn where life gathers. In that patchiness, nests may have been placed on slightly elevated ground to avoid flooding, or near sediment warm enough for incubation, or in places with visibility against predators. The exact choices are unknown, but nest placement is never random in living animals. It balances heat, moisture, concealment, access, and safety. The Gobi nests must have been shaped by similar pressures. Oviraptorid eggs are often discussed in relation to brooding, but incubation may have involved both adult body heat and environmental heat. The adult posture could have shaded or warmed portions of the clutch, while the sediment itself may have contributed to stable conditions. The balance likely differed among species and nest types. Again, the fossil gives posture and arrangement, while physiology must be inferred. Even inferred, the picture is extraordinary. A dinosaur in a desert arranging its eggs in a pattern that fits its body. A reproductive strategy halfway familiar and halfway strange. A nest architecture written into the ground. This is the kind of evidence that makes the dinosaur age less distant. Not by making it modern, but by showing that ancient animals faced problems still recognizable today. How do you protect the young before they can run? How do you keep eggs at the right temperature? How do you eat without being eaten? How do you move through a landscape that may change beneath you? These questions are older than humans, older than mammals as rulers, older than birds as we know them. In the Gobi, they are written in sand. Sand eventually became stone. Stone eventually became cliffs. Cliffs eventually became a place where people kneel with brushes and plaster. The chain from living behavior to museum specimen is long, but every link matters. Break one link, and the story disappears. No burial, no fossil. No exposure, no discovery, no context, no meaning, no caution, no truth. Truth in paleontology is often provisional, but provisional does not mean weak, it means proportioned to evidence. We can say confidently that the flaming cliffs yielded dinosaur eggs, Protoceratops, Velociraptor, Oviraptor, mammals, and lizards. We can say oviraptorid brooding is supported by remarkable nest specimens. We can say the fighting dinosaurs preserved direct interaction and were likely buried rapidly by sand. We can say the exact lived experience remains beyond reach. Those statements are enough to build a documentary world. They provide place, time, animals, behavior, death, preservation, and scientific change. They do not require invented dialogue or impossible certainty. The Gobi's strength is that the real evidence already has narrative shape. It begins with a red cliff and ends with bones still locked in the posture of the lives they lost. The red cliff is still there. The wind still works on it. The modern desert still shifts between emptiness and revelation. A visitor may stand before it and see only stone until a guide points out where eggs were found, where expeditions worked, where the sandstone holds the colors of an ancient dune field. Then, the cliff changes. It becomes layered with animals. Protoceratops moves first because it is common. It crosses the mind in groups, low and sturdy, beaks near the ground. Oviraptorids appear near nests, their silhouettes stranger, their arms longer, their reputation complicated. Velociraptor remains at the edge, not oversized, not roaring, but alert. Around them are smaller lives, half hidden, making the ecosystem whole. None of these animals lived at the exact same instant across every locality named in the Gobi record. Formations span time. Localities differ. Species ranges overlap imperfectly. A responsible reconstruction compresses carefully, using animals known from the Jadakta and related deposits without pretending every fossil came from one day. The aim is not a single snapshot, but a faithful composite of a real ancient environment. This is especially important with Oviraptor and Sitapati. The famous name Oviraptor comes from the flaming cliffs, while many brooding specimens that reshaped interpretation belong to Sitapati or other Oviraptorids from related Gobi localities. For a script, Oviraptor can remain the historical anchor, but the broader group must carry much of the behavioral evidence. That distinction keeps the story accurate. Accuracy does not make the narration less smooth, it simply changes the phrasing. Oviraptor was named from a specimen associated with eggs. Later discoveries of Oviraptorid embryos and brooding adults showed that the old egg thief interpretation was likely wrong, or at least far too simple. The animal's relatives reveal the behavior that the original specimen alone could not prove. The relatives speak across the desert. One nest answers another. One embryo clarifies a shell. One posture changes a name. Science in the Gobi is not a single discovery, but a conversation among fossils separated by rock, locality, and time. The more voices enter, the more complete the ancient world becomes. At the end of the day, the desert darkens quickly. The red cliffs lose their fire and become muted walls against the sky. The wind cools. Small animals would have moved then in the Cretaceous, as they do in deserts now. The big bodies settle. The nests remain. The dunes, which seemed still in daylight, continue their slow work. Under one dune, a fossil waits. Maybe it is a skull, maybe a clutch of eggs, maybe only a fragment of a limb that will never be named. Waiting is not active, but it is real in geological time. The fossil is held until erosion, chance, and human attention meet. Most will never be found. Some will change everything. The Gobi dinosaur graveyards remind us that the past is not evenly preserved. It arrives through accidents, through disasters, through places where sediment behaved in unusual ways. We do not know dinosaurs because the world carefully saved them for us. We know them because some deaths were trapped before they could disappear. That makes each specimen both scientific and fragile. The fighting dinosaurs are not only famous because they are dramatic, they are famous because direct evidence of behavior is rare. The Oviraptor nests are not only famous because they are beautiful, they are famous because they changed an interpretation. Protoceratops is not only famous because it is common, It is famous because abundance lets a species become visible as a population. Population is where evolution happens. Individuals die in sand, but populations change through generations. Frill shapes vary. Body sizes shift. Species spread, decline, or split. Predators adapt to prey. Nesting behaviors persist if enough young survive. The Gobi preserves individuals so vividly that it can be easy to forget the generations behind them. Every fossil body is one point in a much longer line. Follow that line backward, and Protoceratops connects to earlier ceratopsians, small bipedal ancestors, and the broader Ornithischian radiation. Follow it forward, and larger horned dinosaurs appear elsewhere, with bigger frills and horns and different ecosystems. Protoceratops sits in the middle of that history, not primitive in a dismissive sense, but positioned in a lineage still exploring what a horned dinosaur could be. Follow Oviraptor backward, and you meet theropods with teeth, grasping hands, feathers, and active bodies. Follow its relatives sideways, and you meet other Oviraptorosaurs with crests, beaks, nests, and strange skulls. Follow the broader theropod story forward, and birds remain, long after the Gobi oviraptorids are gone. The nest becomes one point in a vast branching tree. Follow Velociraptor, and you enter the dromaeosaurid lineage, close to birds but not ancestral to them. These animals had stiff tails, grasping hands, enlarged second toe claws, and likely feathers. Their success came in many forms, from small agile predators to larger relatives in other regions. Velociraptor itself was a Gobi specialist, known from a world of sandstones and desert-adapted prey. Follow the sand, and the tree becomes a landscape. Dunes migrate, basins fill, rocks harden. Mongolia changes. The animals disappear, but the sediments remain. Eventually, humans arrive with names, tools, institutions, and questions. The fossils cross from one kind of time into another, from biological time to geological time to historical time. Historical time is short. The century since the first great Gobi expeditions is almost nothing beside the 70 million years between Protoceratops and now. Yet, in that century, the meaning of the fossils has changed dramatically. Eggs became evidence of dinosaur reproduction. Oviraptor became misunderstood. Brooding entered the dinosaur record. Velociraptor became famous, then had to be made real again. This is why returning to the fossils matters. Popular images drift quickly. Scientific specimens remain available for re-examination. A name in a book may harden into myth, but a bone can be measured again. An eggshell can be sectioned. A nest can be mapped. A CT scan can reveal what preparation could not. The fossil is a check against imagination that has wandered too far. Sometimes, though, imagination helps scientists ask the next question. If an adult is found over eggs, perhaps posture matters. If sand surrounds a skeleton in a certain way, perhaps burial was sudden. If a Protoceratops frill changes with age, perhaps growth series can explain variation once thought taxonomic. Imagination proposes. Evidence disposes. The two work best when neither pretends to be the other. The Gobi's sandstorm fossils are therefore not simply disasters preserved in stone. They are tests of interpretation. Did the animal die before burial or during it? Was the nest being guarded, brooded, raided, or simply nearby? Was the predator hunting or scavenging? Did rain trigger the sandslide? Was the dune active or partly stabilized? Every answer must pass through rock. Passing through rock takes time. The brush moves slowly. The preparator's needle moves even slower. A crack is stabilized. A bone edge is followed. Matrix falls away grain by grain. The animal returns not all at once, but as a sequence of small recognitions: tooth, beak, claw, eggshell, limb, vertebra, posture. When the posture finally appears, the room changes. A skeleton over a nest is not merely assembled. A predator and prey locked together are not merely adjacent. These arrangements carry the force of interrupted action. They make the ancient world feel less like a list and more like a set of lives caught in the middle of being lived. That middle is the proper place to leave many of these animals. Not at the beginning of dinosaurs, not at the final extinction, but in the middle of daily pressures. Feeding, nesting, hunting, avoiding heat. Moving between patches of water and plants. Responding to storms. Becoming fossils only when ordinary life met sudden sediment. The Gobi Dinosaur graveyards are powerful because they preserve that middle with unusual clarity. They do not show dinosaurs as rulers in a generic sense. They show them as residents of a particular dry world. Protoceratops was not ruling the earth. It was living in a basin. Oviraptor was not a villain. It was part of a nesting theropod lineage. Velociraptor was not a movie shadow. It was an animal that could be hurt. Hurt matters. The broken arm in the famous fossil, the grip of the beak, the trapped claw, the buried nest. These details bring vulnerability back into dinosaurs. Even predators were vulnerable. Even parents were vulnerable. Even common species were vulnerable. The dinosaur age was not invincibility stretched across millions of years. It was life continuing despite constant individual risk. Life continued until it did not, and then the sand continued. That continuity is almost difficult to hold in the mind. The animal stops breathing, but the dune keeps moving. The species vanishes, but the formation remains. The climate changes, but the sandstone waits. The fossil is found, but the desert keeps eroding. Nothing in the chain pauses for our understanding. Understanding is built afterward, with dates and names. Beinzak, Jadokta, Campanian, Protoceratops andrewsi, Oviraptor Velociraptor, Velociraptor mongoliensis, Sitipati, and other oviraptorids. These names are human tools and useful ones. They let us organize the evidence. But beneath the names were animals with no awareness of categories, moving through heat and dust. The name Flaming Cliffs might be the most human name of all, because it responds to appearance rather than geology. It remembers the color. The cliffs themselves were once dunes, surfaces, slopes, and burial places. Humans saw them glowing and named the glow. Science then filled the glow with time. Time is what makes the Gobi difficult and beautiful. A sandslide lasting seconds, a nest active for weeks. A dinosaur growing over years. A species lasting hundreds of thousands or millions of years. A formation accumulating across geological intervals. A fossil waiting tens of millions of years. A field season lasting months. A museum visitor pausing for less than a minute before a skeleton. All of these times meet at the glass. At the glass, the animal is silent, but not empty. The Protoceratops skull still carries the curve of the beak. The Oviraptorid nest still carries the pattern of eggs. The Velociraptor claw still carries the memory of a function, if not the exact motion. The sandstone still carries the desert. The fossil is no longer alive, but it is still doing work. It works against forgetting. Not the forgetting of one animal, which no fossil can truly prevent, but the forgetting of deep continuity. Deserts existed before us. Parents guarded eggs before us. Predators failed before us. Ecosystems balanced scarcity before us. Science made mistakes before us and corrected them before us. The Gobi keeps these patterns in stone. Near the end, return to the nest. The eggs lie in their ring. The adult is gone, or present depending on which fossil we hold in mind. Sand fills the spaces where air once moved. The shell has not opened. The body above it has not risen. The desert has taken the moment, and the rock has kept it. Return to Protoceratops. A skull weathering from red stone. Beak first, frill still hidden. It is not dramatic yet. It is only a shape in a cliff. But inside that shape is a herbivore's life. Food, growth, danger, perhaps group movement, perhaps display, and one place in a dry ecosystem that made room for millions of ordinary actions before one final burial. Return to Oviraptor. Not the thief imagined in the first rush of discovery, but the animal surrounded by better evidence. A name with an old accusation. A body near eggs. Relatives over nests. A story corrected by embryos and posture. The fossil remains what it always was. Our understanding becomes less simple and more true. Return to Velociraptor and the fight. The predator is smaller than legend, feathered in the most likely modern view, precise rather than monstrous. The Protoceratops is not helpless. Their bodies meet with force. Sand covers both before the world can separate them. The fossil does not tell us who won. It tells us that both were real. That may be the strongest thing the Gobi gives us. Reality instead of myth. Not less wonder, but better wonder. Wonder with sediment under it. Wonder with eggshell pores, bone injuries, crossbeds, field notes, revised names, and cautious conclusions. Wonder that survives being examined closely. The value of these graveyards is not that they let us escape uncertainty. It is that they place uncertainty around objects we can still touch with our eyes. The egg is real. The nest is real. The red sandstone is real. The Protoceratops' skull is real. The Velociraptor and Protoceratops locked together are real. Around them, the missing parts remain missing, but the missing parts no longer feel empty. They become the space where careful reconstruction can happen. A dry basin in the late Cretaceous did not know it was preserving a future museum. It only held animals moving through heat, hunger, nesting, danger, and weather. The sand did not know it was recording a behavior. It only moved downhill. The eggs did not know they would become evidence in a debate about parentage. They only held embryos, or the possibility of embryos, until that possibility ended. The fossils matter because none of this was meant for us, and still it reached us. That is the quiet force of the Gobi. It turns accidental preservation into a sustained conversation between life and stone. The conversation is not finished, and it should not be. Somewhere in the same desert, a future specimen may already be approaching the surface. It may confirm what is now suspected. It may complicate what seems settled. It may be small, a tooth or eggshell shard, or large enough to change a gallery. Either way, it will begin the same way, as a difference in the rock. The next layer may not hold a famous animal. It may hold only a fragment, a partial limb, a weathered eggshell, or a small jaw from an animal most people will never hear named. But even a fragment can steady the larger picture. The Gobi was built from fragments before it became a legend. It will continue that way, grain by grain, specimen by specimen, correction by correction, until the desert's quieter evidence becomes part of the larger memory of the dinosaur age. The cliffs are dark now. The red has faded. Wind still crosses the surface, moving grains from one small ridge to another. Somewhere under the stone, more fossils remain hidden. A nest, a skull, a tooth, a body folded by sand. The desert is not finished speaking. It is only waiting for the next layer to fall away.